Good morning. I, Meghna KP of SY Civil, is going to present a seminar on the topic Admixtures in Concrete. What is admixture? Admixture is defined as material other than water, aggregate, and cement that is used as an ingredient of concrete to modify the properties of fresh or hardened water. Now, we will see into the uses of admixtures. Admixtures are commonly used to improve workability, increasing or decreasing cure time, and increasing concrete strength. It is also used for aesthetic reasons, such as to change the color of cement. Then, the next purpose is concrete workability, water tightness, and strength should be achieved by selecting suitable types of aggregate, Portland cement, and maintaining a good water cement ratio. But when this is not possible, or special circumstances exist, such as freezing weather, hot temperatures, increased wear, or prolonged exposure to dosing salts or other chemicals, admixtures can be helpful. Now, next we comes to the benefits of admixtures. The use of admixtures is increased very rapidly because concrete admixtures provide physical as well as economic benefits. Now, what are the benefits of admixtures in the concrete? First one is admixture reduce the required quantity of cement and make concrete very economical. They enhance the workability of concrete. Admixtures imparts early strength in concrete. Admixture reduce the early heat of hydration and overcome thermal cracking problem in concrete. If there is a more heat of hydration, then cracks can propagate in fresh concrete. Admixtures improve the resistance against freeze-thaw effect on concrete. Concrete admixtures maximize the sustainability by bringing waste products in use. Concrete admixtures can accelerate the setting time as well as there are admixtures that decelerate concrete setting time. There are some admixtures that act as antibacterial agents. There are concrete admixtures that decrease initial strength but increase the hardened concrete strength more than the normal concrete strength. So, in common, we can say that the uses are increase workability, then increase workability, increase or decrease cure time, and increase concrete strength. Now, next come the functions of admixture. The function of admixture is that to accelerate the initial set of concrete, that is to accelerate the rate of strength development at any early age. To dim the initial set, that is to keep the concrete in a working position for a longer time for placement. Also, to enhance workability to improve penetration and permeability of concrete. Moreover, to reduce the separation in grout and concrete mixtures. Increase the strength of concrete by decreasing the water content and increasing the density of concrete. To increase the durability of concrete. Also, to reduce the capillary flow of water through concrete and increase its imperviousness. And the next is to control alkali aggregate expansion or alkali silica reactivity. It also prevents corrosion of reinforcement in concrete. Increase resistance to chemical attack. To reduce the heat of hydration. To increase the bond between old and new concrete surfaces. Also, to enhance the bond of concrete to steel reinforcement to reduce the weight of concrete per cubic meter. Now, next comes the types of concrete admixtures. There are mainly two types of admixtures. One is chemical and mineral admixture. Chemical admixtures reduce the cost of construction, modifying properties of hardened concrete, ensure quality of concrete during mixing, transporting, placing, quarrying, and overcome certain emergencies during concrete operations. Now, the chemical admixtures fall into the following categories. They are air retainers, water reducers, set retarders, set accelerators, super plasticizers, specialty admixtures which include corrosion inhibitors, shrinkage control, alkali silica reactivity inhibitors, and coloring. Now next is the mineral admixture. Mineral admixture are more economical, reduce permeability, increase strength, and influence other concrete properties. Mineral admixtures are made from natural materials or substances. Okay, so now mineral admixtures are of there are few types of mineral admixtures. They are now first one is fly ash. Pulverized coal is combusted in thermal power plants for electricity generation. A byproduct of this combustion reaction is fly ash. Fly ash is very fine particle-like residue which has pozzolanic properties. Hence, it is often blended with cement. Now next is ground granulated blast furnace slag. Blast furnace slag is byproduct of iron extraction process from iron ore. Amongst all mineral admixtures, blast furnace slag has the highest specific gravity. Typically, the slag fineness is slightly more than that of the cement. There are various types of slag possible, like air-cooled slag, expanded or foamed slag, granulated slag, and pelletized slag. Among these, only the granulated slag is commonly used as a mineral admixture. It is a high reactive form of slag and it is usually quenched to form a hardened matter which is then ground into particles of fineness almost same as that of cement. Hence the name ground granulated blast furnace slag. Next is silica fume. Silica fume is very fine particles of amorphous silica. It is produced as a byproduct in electric arc furnaces in the production of elemental silica or other silica-based compounds. Silica fume is highly pozzolanic in nature. Next is rice husk ash, which is very commonly used and it is very cheap. Now we will see into how this is processed. During milling of the paddy coming from fields, a lot of rice husks is produced. This rice husk is mostly used as fuel. Rice husk ash is produced by burning the rice husk. It is about a quarter of the mass of the husk. The rice husk ash is a big threat to the environment where it is dumped. Rice husk ash can be produced by field burning. Produces poor quality ash, bed furnace burning and industrial furnace. Rice husk ash contains a high amount of silica. Now, the next topic is plasticizers. Plasticizers comes under the category of chemical admixture. So what is a plasticizer? Superplasticizers are also known as plasticizers or high-range water reducers. They reduce water content by 12 to 30% and can be added to concrete with a low to normal slump and water cement ratio to make high slump flowing concrete. Flowing concrete is a highly fluid but workable concrete that can be placed with little or no vibration or compaction. The effect of plasticizers lasts only 30 to 60 minutes, depending on the brand and dosage rate, and is followed by a rapid loss in workability. As a result of slump loss, plasticizers are usually added to concrete at the job site. Now, the importance of plasticizers are to achieve a high strength by decreasing the water cement ratio at the same workability as that of an admixture free mix. To achieve the same workability by decreasing the cement and to reduce the heat of hydration in the mass concrete. To increase the workability to provide ease in placing concrete in inaccessible locations. The use of plasticizer is found to improve the desirable qualities of the plastic or green concrete for making reinforced concrete or mass concrete of higher workability nowadays. It has become a standard practice to use plasticizers or superplasticizer. Nowadays, the use of superplasticizers have become a universal practice to reduce the water cement ratio for the given workability. The reduction in water cement ratio increases the strength and improves durability of the concrete. Sometimes plasticizers are used to reduce the cement content and heat of hydration in mass concrete. The essence of good quality concrete is the requirement of high workability under different situations. Concrete of different degree of workability is needed. A high degree of workability is required in situations like deep beams, thin sections, and high percentage of reinforcement. Beams and column junctions, piping of concrete, trim concreting, hot weather concreting, etc. The conventional methods of improving workability are by improving the gradation of increasing the quantity of fine aggregate or by increasing the cement quantity. In the field, there are limitations and difficulties to obtain high workability under the given set of conditions. In the field, in most of the cases, generally extra water is added to the concrete and mindful of its ill effects on the properties of concrete. The use of extra water is very harmful and should never be used. The use of extra water will not improve the inherent good quality such as cohesiveness and homogeneity of the mix, which reduces the bleeding and segregation of the concrete. So now I conclude my seminar. Thank you.